Okay, today let's dive in, no intros or anything, into our surds. Now, apart from surd sounding really cool, surd, like, come on, isn't that a cool name? Can the surd be heard? No, okay. So, surd laws are the same, we'd expect them to be the same as exponent laws, because, like, here, if we're multiplying, then, and we're taking the same root, if I don't know, it just feels to me like our rules are going to be similar and they kind of just make sense. So let's look at some examples here. If we're taking the cube root of 2 times the cube root of 4, it's the same as the cube root of 8, because it's the cube root of both of these things. Now, the reason I say it feels like exponent laws anyways, if we've got the cube root of something, like the cube root of x, what's another way of writing that with just x as our base? What would our exponent be? Well, it would be 1 over 3. So x to the 1 over 3 is another way of writing cube root of x. So therefore, if we've got x to the 1 over 3, like here, we're going the nth root of a times the nth root of b. So let's rewrite this in exponent form. And I'm not going to do this for all of these, but just to show this point, because I think it's a valid one to make. That is, the nth root of a is a to the 1 over n. The nth root of b is, well, not b to the 1 over n. Well, we know that we've got an exponent law that says ab to the something. It kind of just applies to each of those. So we've already got an exponent law like that. And we've already got a definition that the nth root of a and a to the 1 over n are defined as the same thing. So that's why they feel the same to me. But maybe not to you. The reason I'm pushing this point and why I've spent 2 minutes going on about it is because they're not like 4 more rules to learn. Like they're still rules that we've been using. Okay, so that's that. Here they all are. We'll use them shortly. What's more interesting is this. And it kind of exploiting those rules. If we're writing surds in simplest form, well, this idea of separating it out, it's almost like that split and factorize type thing of, but not quite. Of 18 we could write as 9 times 2. So what we want is we've got a square root, so we want to try and find some square numbers. Because the square root of 9 is 3, and that's where we're simplifying. So if we've got the square root, we're looking for square numbers. So let's dive in straight into an example to see what that means. So I think we need to work through one. We've got the square root of 20. Now, what perfect square number goes into 20? Well, I think 4 goes into it. Is that the highest number? 4, 9, 16, 25, yeah. So 20 we could write as the square root of 4 times 5. And just focusing on that part, we could write as the square root of 4 times the square root of 5. That's what our surd laws tell us. Which means the square root of 4 is just 2, so that's 2 square root 5. Let's move a little bit out the way here. Maybe all the way out there. So what we've done is we've taken, just above my head here, the square root 20. We've rewritten as square root 4 times 5, because 20 is 4 times 5. And the reason we've done that is we've looked for kind of the biggest square numbers we can. So we could separate that out so that square root 4 becomes 2. We could even check ourselves by going, the square root of 20 equals 2 root 5. Okay, so we're just using our calculator to check us. 2 square root 5, 2 root 5. Now, when it gets to actually doing these things, we'll do it with variables so that we can't just use our calculators. But let's use but we're using real numbers for now. Minus the square root of 45. We're looking for perfect squares that go into 45. 1, boring. 4, 9. 9 goes in, cool. 16, 25, 36. So it seems like 9 goes in there. And the reason that we want that is that we're going to have a square root of 9 to give us 3. So the 9, square root 9, 3. 9 times 5. Square root 9 times square root 5 minus 3 square root 5. So in other words, we look for a perfect square. Okay, over square root 5. Square root 5 over square root 5. Now there are two ways of going at it from here. 2 square root 5 minus 3 square root 5 over square root 5. What does that equal and why? Well, one way to look at it is we've got 2 of these square root 5s and we're subtracting 3 of them. So we've got minus 1 of them over square root 5 equals square root 5 goes in there once and once. So we're just left with minus 1. That's cool. Another way of looking at it, which is kind of interesting, is to say, hey, we've got a common factor, 2 terms. So we're taking a square root 5 out, 2 minus 3 over square root 5. 1 term over 1 term. Happily do that. 2 minus 3 minus 1 over 1 minus 1. Two different ways of getting there. Okay, so let's just look at the kind of the concept of these three without going too much. I know I'm looking at the time here of 6 minutes in. It's so easy to get carried away with these. So forgive me, but enjoy. So let's get in here. Square root 32, square root 80, square root 50, square root 288. Okay, so again, the idea is let's look for perfect squares that go in here. 32, what's the highest perfect square that goes into 32? Well, 16. 16 goes in there twice. So this is clearly going to be the same as the square root of 16 times the square root of 2, which we're going to simplify to 4 square root 2. Okay, and then we can go along. Highest square number that goes into 18, 9. So therefore, what does square root 18 simplify to? Well, square root 9 times square root 2. Okay, plus square root 9 times square root 2. Square root of 9 is 3, so we got 3 square root 2. What's the highest perfect square that goes into 50? 25. Square root of 25. So I'm going to jump to this step, but you have to show this step because otherwise you just punch in your calculator. So play the game here. Practice your working with your surd so we can do it with algebra. So 25 goes in here, so this will be square root 25 times square root 2. So it'll be 5 square root 2. But as I said, let's just show that step 25 times square root 2. But keep thinking that concept, square, square, square. So square root 288, biggest perfect square that goes in there. Clearly 144 goes in there, right? So that's 12. So 12 square root 2 is what we're going to get to here. And then it's going to look like the one we've just done. 4 of these square root 2s plus 3 of those square root 2s plus 5 of those square root 2s. We've got 4 plus 3 is 7 plus 5 is 12. 12 of them over 12 of them gives us 1. Again, I don't want to get into the nitty-gritty of which steps must you show. The concepts, just work through it. And show the steps that we need to. But we'll cover which bits you kind of have to show. Okay, this one's going to be quite similar. And this one here looks a bit more interesting because it looks like we should multiply that in, but it doesn't look like it's going to help us much. So let's rather see what we can do inside. I'm going to skip all of the steps that please do show because they're useful. But let's just get into that concept of what's the biggest square number that goes into 75. Well, 25 goes in there. 25 goes in there 3 times. So if 75 is 25 times 3, square root 75 is square root 25 times square root 3. So square root 75 is 5 root 3. So 5 root 3. And look how useful that is, because now when we multiply these in, that square root 3 times that square root 3 will give us 3. Cool, right? So let's do this other one. Minus 3 square root 6. Again, there's no nice square root number that goes in here. But at the very least, 6 could be written as 2 times 3. So this could have been minus 3 square root 2 square root 3. at least that square root 3 times that square root 3 will end up nicely. So I'll just run through that quickly for you. Sound okay? Okay, so 2 square root 3 times 5 square root 3. 2 times 5 is 10. Square root 3 times square root 3 is 3. Minus, that's that minus. 2 times 3 is 6. Square root 3 times square root 3 is 3. Times square root 2 equals 30 minus 6 times 3, 18 root 2. Like, it's still got surds in it, but, you know, it's something. So, enjoy exercise 5. As I said, show the steps, but focus on kind of that logic of working with your surds and getting used to that. Oh, there are only like 6 of them. That's easy, right? So, enjoy. Goodbye.